So we have a Rodin coil, and a Rodin coil can be created with a 24 by 24 matrix. So if you took those 6 by 6 matrices and you add 15 of them, so they're 4 by 4, 16 of those 6 by 6s, you create the matrix for a Rodin coil, which is this guy right here. And a Rodin coil still has 2 electric circuits, but they move in 288 steps, not 8. There's not just the 18 steps. If there's 288, that means the number of 18-step cycles in it is actually 16. There's 16 cycles of positive and negative charges moving through one current. And this is just one star. As you can see the marks for the other circuit that would go there. We'd have 2 of the circuits evenly spaced. This is one thing I had a problem with the Marco's math for a long time, is having this third space. It didn't make sense when I was working with electric fields. It just did not make sense. Because if you had the third space, and I always saw as one being positively and negatively charged, all it does is sort of create a fractal structure. You have 2 spaced here, and there's going to be a boundary layer in between them. But then if you're missing something, you're just extending your boundary layer in between the 2. You're just creating almost like a polarized electric field. It's going to be moving in one direction more than the other, which isn't necessarily a bad thing. Okay, so what else can I show you? Let me explain. Before I do that, I'll just quickly post this up. These are ratios for the coils. We got a ratio for the triadic coil and a ratio for the Rodin coil. The triadic is a 2 to 1, so that's the 2, that's the 1. The Rodin coil is 3.867 to 1, and this will have the wire conform to it absolutely perfectly around the coil. How you'd make this, I don't have a picture of this one, but how you'd make this one a sine wave, these are triangular waves, is you'd use a 3-point arc going between these points right here. I'll get an image of that to show people. I just don't have one for this quick presentation. Alright, I'm going to explain this concept because so many people don't understand it, and I've talked to people about this many times. They always look at me screw-eyed when I talked about the different forms of magnetism. What I've said before is just go to Wikipedia, read about all the different types of magnetism, and understand the different types of flow. I'm going to talk only about 3, but you got paramagnetism, ferromagnetism, and diamagnetism. There's also antiferromagnetism and ferrimagnetism, and then there's 2 complex forms of magnetism, super diamagnetism and super paramagnetism. So there's 5 immediate ones and then 7 total, and then 3 primary, which is sort of interesting to think. 3, 5, and 7, big numbers. Okay, so ferromagnetism is one everyone's familiar with. This is just your traditional magnet. Okay, so let's say this is the Earth. This is north, and this is south. Okay. Materials are ferromagnetic are iron, cobalt, and nickel. It's a very rigid form of ordering, magnetic ordering. And so this is, say, the Earth. Okay? It's like a ferromagnet. Now, what happens when you have a paramagnetic substance in the presence of a ferromagnetic substance? It will magnetize to the flow. It responds to the flow. It's a very loose form of ordering, but will not retain any magnetization, while these will. So these cannot be permanent magnets. They can only become magnetized temporarily when in the presence of a magnetic field. And so this shows that the magnetic field line coming out, this north connects with this south, and so this is how a compass works, except we use the ferromagnet will still respond the same like a paramagnet, but the north ports to the North Pole, but it's really a south magnetic pole. It's following the line. Alright. Now we got diamagnetism. Diamagnetism is super, super cool, and a lot of people don't realize the potential of it, and this is something that people really need to jump up on the bandwagon and start understanding. So diamagnetic materials are like copper, gold, silver, carbon, bismuth, tin, lead, mercury. Bismuth is the most diamagnetic substance we know of, or element. Carbon is 4 times more diamagnetic when it's in pyrolytic graphitic form, but that's it. Anyways, what happens to a diamagnetic substance? It becomes perpendicular to the magnetic field, or in the presence of a magnetic field, temporarily, just like a paramagnet. And so if you have this diamagnet or diamagnetic substance above the equator, essentially, it's going to repel it perpendicularly. So you got south-south, but it's also opposed to it. And this one's north-north. And so actually when a diamagnet flips across this null zone, the center point, it will flip, and it will go north-south. That's also an effect that can be exploited with it flipping. That's something that actually happens within one of these toroids. Is you can get the diamagnetic substance spin. You can create a rotating diamagnetic field just like you can create a rotating magnetic field. And what's interesting to think about this is think about us. Alright? We're made of water, we're hydrocarbons, we're diamagnetic substances. So are trees, so is limestone like the pyramids are made out of. And guess what? They're perpendicular to the magnetic field of the Earth. And that we're creating diamagnetic fields perpendicular to the Earth. Our structures are naturally made to resonate these types of flows. We aren't laying on the ground magnetizing if we were all iron. No, we're standing up. It's the whole idea of also when you're meditating, you're creating this diamagnetic flow with you when you're perpendicular to the ground. So, now what's important about that is understanding how to properly build one of these guys. Alright? Now, this is what I'm going to quickly talk about and how you want to properly build a Rodin coil. This one will still work. It just doesn't want to do exactly what I want it to do. This one's falling apart a little. But this has a water core, which is diamagnetic, and a type of clay that's diamagnetic around it. Ideally, you want this whole thing to be a diamagnetic conductive substance, because this is what you're basically creating. You're creating eddy currents that you want to control, eddy currents that have capacitance that feed off of each other. And so, when this is diamagnetic, and you're, say, pulsing this, okay? You're pulsing this with the correct resonant frequencies. And the resonant frequencies for the coil would be the wavelength from here to here. This is for a triangular wave. And it's going to be a little bit hard to calculate, but that would be your wavelength you need to figure out for the resonant frequency of the coil. And then there's also multiples of it. There's going to be another resonant frequency that's 3 times that going through the coil. So, what happens when this is diamagnetic is it pushes the magnetic field outside of the coil. It actually pushes it out. If you think about it, in the word diamagnetism means through, and para means around. You want the magnetic field to go around the coil, and the diamagnetic force is going to be through the coil. Okay? And so, when it gets pushed out, it's not getting absorbed into the coil, because you're creating a diamagnetic field in the coil. And it's going to be rotating. You're going to have like little magnets in it spinning around. You can almost imagine it like there are gears pulling in the energy. So you can think of a bunch of gear cogs like this inside spinning. This is your rotating diamagnetic field. Now what happens when the magnetic field's pushed out? Say if the magnetic field, you got this much diameter of this little hole, say that's the same on the outside, and you're able to just concentrate the magnetic field to this far outside and within this whole surface right here. Alright? You're going to be getting compression. The magnetic field is going to expand this whole ring on the outside, but then it compresses to the center. You get implosion. You start imploding the magnetic field. That is the key thing to making the Rodin coil work. You could just do this with a diamagnetic substance like plaster of Paris to implode the magnetic field. But what happens when it's conductive is you create eddy currents in it. This essentially becomes like a transformer, except it's stepping down the current into the toroid. And the toroid, when it starts to become in resonance, and you have the capacitance and inductance balanced within the coil, essentially you have your perpetual motion toroid, and it's going to start pumping energy out into the circuits once it's moving. The key to really make it moving, though, is superconductivity and getting this guy cool. And you can use the implosion of, say, a ferrofluid to cool this coil down to a superconducting temperature, and then you have a real free energy device. What helps is to put something in the center of it, something very thermoconductive. So when the ferrofluid's compressed in the center of this, that heat can be pulled away with that thermoconductive substance. and this guy will start to cool. And so the real keys to making a coil work is understanding implosion, resonance, and there's one more. Implosion, resonance, and superconductivity. Really understanding those concepts is how you're going to get this device to work, which are really all traditional concepts in physics, just putting them together. Another thing I want to share with you is where you can get toroids that already have that geometry. The play school ones here happen to have the two bottom ones are really close to the ratios for the triadic coil. If you cut them in half and use the inside as a mold, it probably would be perfect. But don't quote me on that. They're really close. However, these new Scotch tape dispensers, they happen to be almost exactly dead on for a Rodin coil geometry. Go figure. So you can make a mold out of these, which I'm doing right now as we speak. So there's two things in the stores that already have those geometries that you can use to make the molds. What I'm going to be doing is I'm going to be making a mold out of this guy, and I'm going to be putting an alloy of bismuth and tin into it. It's a diamagnetic conductive substance that can also superconduct. And the alloy is alloy 281. It's 58% bismuth, 42% tin. Tin is also a diamagnetic conductor. So, one little thing. Wait, are you over here? Alright, so, this is a diamagnetic conductor. However, it's weakly diamagnetic. However, one way to increase the diamagnetic response in a material, which can also be done with aluminum, which is paramagnetic. Many of you probably have seen this idea before, is I'm dropping a magnet into this guy. Boom! And it takes a long time for it to fall down, because when this magnet's moving through that pipe, it's creating eddy currents in the pipe. It's creating a changing magnetic field. When you have a changing magnetic field in a conductor, it creates a very strong diamagnetic response. This magnet is actually being repelled, or it's not complete repulsion, but prevented from falling down. There's diamagnetic resistance, essentially, on that magnet. And that's something to think about. I'm going to hold up really quickly one circuit diagram. Here you go. Alright. Of how you could fire the triadic coil. You could do this with the Rodin coil. This is mixing with the Tesla coil setup. We got two capacitors here, and so you can create really big capacitors which you can do yourself with just plates, or putting say one metal tube inside another tube with a dielectric. A really good dielectric I've been studying is magnetite powder and epoxy resin. 30% magnetite powder. It has some really, really crazy effects. I could probably talk about for 10 minutes about this dielectric, but it's a simple homemade high voltage, high K dielectric. And instead of making a transformer with tons of primary winding to pull tons of power from the house, you could use the capacitors to create a lot of charge. Spark gap, transformer, ground hooked in the middle of the transformer, your secondary transformer with the ground hooked in the middle of the transformer, another capacitor, and then two diodes. And basically what happens is you're stepping up the voltage, and this is your secondary circuit, and it's pulsing it. So you have one input on this side and one input on that side, and it's pulsing it. So every half cycle is getting it will fire here, and then when that negative charge is right here, that one's firing. And so you're going to have the negative charges traveling together and also creating positive holes. And the positive holes will travel together. And so you get superconductivity happening even up possibly at room temperature, which is the real goal. But I think mixing the superconducting materials is your true powerhouse.